Okay, so seems to be fine. So this is what I'm going to call it the review. It's very important. The review part start with the from calculus 1, be reviewing substitution method. Okay, you get quite a lot of these type of questions. And then if you want to practice, you go to that okay, handout that I posted for you. So it's going to be substitution method. Substitution method. Or integration by substitution method. Okay, just remind you that recall. Okay, recall that if f is a continuous function, and u equal to the u of x is a differentiable function. Is a differentiable function. If it's going to be differentiable function of okay, differential function of x. Differentiable function means we can find the derivative. Then if you want to find the integral of okay, integral of f of u, d of u, this is going to be the same as integral of f of u of x times u prime of x times d of x. Okay, that's a change of only and change of variables. Okay, so where d of u, which is a differential of u, is simply u prime, okay, u prime dx. So this is the method of substitution that we usually use. Okay, there is a special format. So in particular, if you like, or a special one, if this function is going to be a power function, it's going to be u equal to u to the n. Okay, if it's going to be the case, then what we are going to have, this is going to be integral of u to the n. Okay, this is the one. Integral of u to the n du is going to be, okay, it's going to be the same as integral of u to the n. Okay, u to the n times u prime of x dx. And you know that by the power rule, this is going to be u to the n plus 1 over n plus 1 plus the constant c. So basically integral of u to the n du is going to be equal to the u to the n plus 1 divided by n plus 1 plus the constant c. Okay, this is going to be the case. Of course, these formulas can be used only if n is not equal to the -1. If n happen to be equal to the -1, later on, we are going to introduce the natural log and then use the natural log formula for that one too, okay? So this is going to be the special case that we have. You know that this is going to be called, and this is called the general power rule. Okay, so this is going to be the general power rule of integration. So if you have only x to the n, okay, so this is going to be x to the n plus 1 over n plus 1. And if you have u to the n, it's going to be u to the n plus 1 over n plus 1 plus the constant c. Very important formula for us, okay? And both formats are going to be used. So give you some examples of how we're going to operate with this one. Okay, so what is going to be example? We want to find each integral. Find each integral by substitution. Substitution method. Okay, these are all the possibilities that we're going to see through this course. The first one is just an ordinary one, something like 5 times 5x plus 1, everything to the 10 dx. That's it. You know that this is the opposite of the chain rule. So this type of differentiation is the one that you use for chain rule. So as soon as you see a parenthesis raised to something, it's a substitution method. So what we're going to do, we're going to take the inside one to be u, and you have to show that this is u to the n. So it's going to be u is equal to the 5x plus 1. Okay, then you find the du, differential of the u. You know that du is going to be u prime dx. U prime, derivative of the 5x plus 1 is 5. So it's going to be 5 dx. Then you find the dx, so the dx would be the du over 5. Okay, go back and substitute. So integral of the 5 times 5x plus 1 to the 10 dx is going to be equal to 5. We don't have anything to substitute for the 5. We keep it. 5x plus 1 is u, so it's going to be u to the 10. U to the 10 dx. And the dx is simply du over 5. So the 5 and 5 would cancel out. So you arrive at u to the 10 du as you predicted. You see, that's a power function. If you do the substitution, you must get u to the 10, which is a u to the 10. So the power rule, action of integration, is going to be u to the 11 over 11 plus the constant c. Now we substitute for the u, and we are going to be having, so it's a 5 times 5x plus 1 to the 10 dx is going to be equal to what? Is equal to the 5x plus 1, everything to the 11 over 11 plus the constant c, and you're done. Okay, so this is the type 1 of the examples that we're going to have. So this you get the u here, it's going to be u to the 10. So you have to change it to the u to the 10 du. So we take the u to be 5x plus 1. So you find out du. Du is going to be differential of the u prime dx. U prime would be 5. So you find the dx, which is a du over 5. Okay, so you go back, substitute. You must arrive at u to the 10 du. And then action of integration would be u 11 over 11 and the c, and you're done. Okay, now there is a short form that you can do. You can do this one all the time, but this is calculus 2, and then you get a calculus 3. You know, it's optional, but I show you. If you want to use it, I don't mind. See, when we get more experience in this course, because in this course, we may have to do several other actions in one problem. So if you know some shortcuts, that would be useful. It's the same thing. So the shortcut is going to be, see what was the problem? The problem is 5 times 5x plus 1 to the 10 dx. You see, the format is going to be, this is a u to the 10. Remember, so look at this formula. So this is going to be u to the n. You need the u prime here. U prime dx is the one that you call it the du. So you may look for the u prime. You see, that's going to be the one. If you call this one u prime would be 5. This is u prime. So what you can do is you can switch it. So it's going to be 5x plus 1 to the 10. To the 10. And this is going to be 5 dx. 5 dx. Now look at this. Now if you call this one u, what is this? This is du. Okay, so it's just a brief form. So you may think about it that, oh, if I call u to be 5x plus 1, it's just for your information. Then the du would be what? Du would be 5 dx. So you arrive at what? You arrive at u to the 10 du, which is u11 over 11 plus c. So it's going to be 5x plus 1 to the 11 over 11 plus c, and then you're done. Even you don't need this part. As soon as you identify the du, you have the u to the 10 du. So basically, in the short form, this is the way we write this solution. 5 times 5x plus 1 to the 10 dx. I switch it. It's going to be 5x plus 1 to the 10. And this is going to be 5 dx. So I think I said, oh, this is u. And this is du. So action of integration, you add 1 to the power. 5x plus 1 to the 11 over 11 plus c, and then you're done. You see, when we go on, we get more experience. You may, we expect to eventually to be able to do these type of problems, but it's optional. It's optional. You can substitute the u all the time. You get it. There, from time to time, you have to use some tricks to be able to do it. But it's calculus too. So if you know more methods, that would be useful for you. But I don't mind on the test, whichever you meet. You're right. But there are some tricks that you have to do. It's not always as easy as it seems to be. But I show you those methods as I go on. Okay, so you're welcome to just do the full substitution for us. To get the result was just a short form that it's always available. Okay, whatever it's raised to is u. U to the 10. You need u prime. U prime is 5. You have the 5? Yes, I have the 5. It's a deal. You see, when you have the 5, it's a deal. Why? Because the 5 dx is the du. So it's the u to the 10 du. Would be u11 over 11 plus c, and then you're done. Okay, so that was a type 1. Give you another one. Type 2. Type 2 is a radical one, you see. Let's have something like the 5th root of the 3x plus 1 dx. You know that in calculus, we don't like the radicals. So we remove the radical first. Solution. That's it. So we have to rewrite it at 3x plus 1 dx. We rewrite it as a 3x plus 1 to a 5th dx. Now it's a parenthesis raised to something, so it must be done by substitution method. The inside is the one that you call it u. So you have to arrive at u to a 5th du. So do the full substitution. U would be 3x plus 1. So the du would be, derivative of the u would be 3x plus 1 dx. So we find the dx, which is a du over 3. Go back, substitute. So you have the 3x plus 1 to a 5th dx, which is going to be equal to 3x plus 1 is u, so it's going to be u to a 5th dx. What is the dx? The dx is the du over 3. You see there is an extra term here, is a 1/3. 1/3. You cannot simplify it, you can pull it out. So it's going to be 1/3 u to a fifth, okay, du. That's exactly what you were expecting, because that was 3x plus 1 to a fifth. So we change it to the u to a fifth du. Okay, now action of integration. Action of integration, you add 1 to the power. 1/5 plus 1 is like 1 plus 5, which is 6/5. Okay, it's going to be 6/5 divided by the 6/5 plus the constant c. Use the reciprocal for the 6/5. It's going to be 5/6. 5/6 u to the 6/5 plus the constant c. Substitute for u and u that. 5/6, 3x plus 1. Okay, to the 6/5 plus c, the final answer. Okay, so it's going to be a radical function. We always change the radical to be able, to take care of it. Okay, so that's what's 3x plus 1 to a fifth. As soon as we get the parentheses, you must use u substitution. We take the u to be 3x plus 1. You have to find the dx. So we find the du, which is going to be 3dx. We got the dx, du over 3. Go back, substitute. So that gives you u to a fifth. Du over 3. You cannot simplify the 3, you pull it out. 1/3 to the fifth du. Then action of integration, you add 1 to the power. So 1/5 plus 1, which is going to be 6/5, divided by the 6/5 plus c. Use the reciprocal of the 6/5, 5/6, and you substitute and do that. Okay. Now, if you want to get that shortcut that I tell you, it's a tricky one. See the shortcut for this one. So we start by switch it first. 3x plus 1 dx. Now this is going to be what? 3x plus 1 to a fifth and the dx. Now, you see u is 3x plus 1. You need u prime. U prime is 3. There is no 3 here. You see what you can do is you have to create the 3 here yourself. Okay, so u prime is 3, you see. U prime is 3. So what you can do is you need a 3 here inside. So imagine this is a kind of 1 here. So 1, you can write it as a 3 times a third. So this is the way we use this trick. We need a 3 inside. So we divide the outside by 3 and we multiply inside by 3. You see? Because 3 and 3 would cancel out to get the 1. If you need 5, 1/5, 5. If you need 2, 1/2, 2. So always, it's a number. When it's a number, you can always create it. So that would be 3 times 3x plus 1 to a fifth dx. There you are, you get u prime. So you switch it. So that gives it 3x plus 1 to a fifth. And this is going to be 3dx. As we did it above, you see this is u. And this is du. Look at your du here. 3dx. So this is simply u to a fifth. Since we get the u to a fifth, so action of integration, you add 1 to the power, is going to be 1/3. 3x plus 1, power up 6/5, 6/5. Okay, plus the constant c. Okay, because this is already u. So to just use the reciprocal of the 6/5, it's going to be 1/3 times 6. Okay, so this is going to be 5/6. This is a 6/5, it's a 5/6. Times it by 3x plus 1 to a 6/5. Probably we missed something here. Yes, you see we missed the 1/3 here. That's good to check the second method because we find out that we made a mistake here. There's a 1/3 here, I missed it. It's a 1/3. So it's a 1/3. So that's going to be 5 times, that would be 18. I missed a third here, 1/3 times. Okay, 5 times 1 would be 5, 6 times 3 would be 18. So it would be the same thing here. So the final answer would be 5/18. Okay, 3x plus 1 to the 6/5 plus the constant c. Again, it's optional, but you better learn it if you want to calculate 3 later on. Because things would getting a little bit more, not complicated, more involved in future. So you may have to do this one through a problem several times. So if you know these type of tricks, that will help you quite a lot for the rest of this course. But again, we don't mind. You can always go through all the solution that you have. Okay, so basically, this is a u, 3x plus 1. We are going to create the u prime here. U prime is 3, so we need a 3. You can do it only when it's a number. When x is missing, you can't do it, of course. Okay, so u prime would be 3. So what I did, I multiply by 3 and divide by 3. Because 3 and 3 would cancel out, that give me 1. Okay, so as soon as I create the 3 here, so I have the u and the du. So it's a u to a 5th du. Would be u to the what? 6/5 over the 6/5 plus the constancy. Again, it's optional, but I suggest, to keep in mind this type of easy method, because it would be very useful for us. Okay, so that's the case 2 with the radical. Case 3 is going to be a rational function. Okay, suppose you want to integrate something like 2x plus 1 over x squared plus x plus 3, everything to the 10 dx. So that's 1. For the rational function, if this power is going to be 1, we stay where we are and we learn the method of a natural log later on. But for the time being, so what we can do is we move this one up. Okay, we move it up and then we use the same method, the previous method that we had. Okay, so the solution is going to be, I just rewrite it, 2x plus 1, x squared plus x plus 3 to the 10, move it up. So that gives you 2x plus 1 times x squared plus x plus 3, everything to the negative 10 dx. Now again, we have a power function. For the power function, you are going to take this one to be u, and you must end up with the u to the negative 10. So you have to do the substitution method, u equal to the x squared plus x plus 3. That's going to be the u, then we get the du. Du derivative would be 2x plus 1 times it by the dx. Okay, then you find the dx. So the dx would be the du over 2x plus 1. Go back, substitute, you must end up with u to the negative 10. So what we have, this is the given one, 2x plus 1 times x squared plus x plus 3 to the negative 10 dx. We don't have anything for the 2x plus 1, we repeat it. This is u times the dx, but the dx is what? It's a du over 2x plus 1. Now the 2x plus 1 and 2x plus 1 will cancel out. You get the integral of u to the negative 10 du, as we predicted, because that was the negative 10. Now action of integration, that give u to the negative 10 plus 1 would be negative 9 over negative 9 plus the constant c. We don't accept any negative power, so we bring it down. It's going to be negative 1 over 9u to the 9 plus c. Substitute 9 times u, x squared plus x plus 3 to the 9 plus the constant c. Okay, so this is going to be the way we do it for the rational function, but the shortcut for this one is really very easy, and we suggest this one, shortcut. Again, we have to move it up, so that's a 2x plus 1, and that's x squared plus x plus 3 to the negative 10 dx. Again, you see, you take this one to be u. You look for the u prime, but u prime is 2x plus 1. U prime is already here. So switch it. So going to be x squared plus x plus 3 to negative 10. And that would be 2x plus 1 dx. There you are. If we take this one to be u, this is simply what? Du. So we have u to the negative 10 du. Action of integration. Add 1 to the power. It's going to be x squared plus x plus 3 to the negative 9 over the negative 9 plus c. That's it. No negative power, so bring that power down and you're done. 9 times x squared plus x plus 3 to the 9 plus the constant c, and you're done. You see, these short form are very useful for you. You better, get the idea and try to operate. Again, we don't mind if you do it, but it takes times. And these are the type that's easy. The type that you have to do those methods, I'll give you one in a minutes. Okay. So if you haven't done in this type of short form in calculus 1, try to do it from time to time. That would be useful. But if you feel comfortable to just do the original method, we don't mind. You can do that. Okay. So that's a rational function. The other case is when this power is 1. We talk about it later because we need the natural log. Okay, so come number 1, 3. And number 4 is, this one is different. There is no shortcut for this one. And this problem is going to be repeated a couple of times in this course. Just want to make sure that you have seen this one in calculus 1. And this is this famous integral x radical x minus 1 dx. You will see this integral in chapter 7. But let's see how we're going to do it now by method of substitution. Okay, as usual, we change the radical first. Solution. So going to be x radical x minus 1 dx, which is x times x minus 1 to the half dx. You see, that's what we did so far. Now, we see that this is to the half, so we take the u to be x minus 1. Okay, as we did for the others. So we take the u to be x minus 1. Then we have to find the du. Du, derivative of x minus 1, is just 1. So there is going to be 1 times dx, which is a dx. So the dx and the du are the same. Okay, now we try to go back and substitute as we did it for the other. It's going to be x times x minus 1 to the half equal to, we don't have anything to substitute for the x, so we get the x and we hope to be able to cancel it out. Now, x minus 1 is u, so that gives you u to the half. And the dx is the du. You see this one? For all the other problems, this x was canceled out, but not for this one. And you cannot continue, you see, it's a du, so you should have only u. So it's very a special problem. So what we're going to do, we are going to go back here and we find the x in terms of the u. It's only something special, and we are going to do this type of problems from time to time in calculus 2 and 3. So we say, oh, u is x minus 1. So I find the x. X would be u plus 1. So go back here. So we repeat it again. It was x times x minus 1 to the half dx. You see, for the x, we substitute u plus 1. U x minus 1 is u, so it's going to be u to the half. U to the half du. You see? Everything in terms of the u. Now to integrate it, you distribute it first, you multiply it. U to the half times u would be u to the 3 halves, plus u to the half times 1 would be u to the half, and the du. See? Now we integrate it. Power rule for the first one, u to the 3 half plus 1 would be 5 half over the 5 half plus, okay, u to the half would be u to the 1 half plus 1 would be 3 half, and the 3 half plus the constancy. Use the reciprocal of the first one, it's going to be 2/5. 2/5 u to the 5 half, and this is going to be 2/3 u to the 3 half plus the constancy. Now substitute for u. Is it 2/5 x minus 1 to the 5 half plus 2/3 x minus 1 to the 3 half plus c, and you're done. I don't usually change it to the radical. In your book, they go on and change this to the radical, but you don't need it. So that's a very famous problem in this course. But when we get to chapter 7, we have a method, we call it integration by parts. So we can do it by using integration by parts method. But we get to it when we get to that one. So this is just a review for the method of substitution. You have some problems on that handout, and you just go over it. I will post another one for you, but I'll talk about the briefly exponential function and the natural log function. I do it over the weekend for you. So just read the syllabus and remind yourself about the method of substitution and start. You can do a couple of those problems that I posted for you. Okay, check there is something that we call it review, problems on substitution method. So check it. You can do a couple of them so far. But okay, so that's a review from Calculus 1 and the syllabus for our first introductory section, if you like. So if you have any question regarding the syllabus so far, email me. Email would be a good one. I should reply to your email in 24 hours. If you don't see it, you suppose that I didn't get it. So you can do it again. you can email me through the Canvas, or you can email me directly. Okay, and be happy to answer your questions. Okay, so review method of substitution so far. Okay, that's it. Have a good day. Take care and study the syllabus again. So in the next part that I'm going to post for you is going to be a brief introduction to the exponential function and the natural log function from chapter 6. Have a good day. Bye-bye.